Welcome back, everyone, to Lesson 2. Today, we are going to learn how to design an experiment that we can use to test the research question that you came up with during Lesson 1. By the end of today, you're going to be able to go outside like me and collect data for your research project. During today's lesson, you're going to be using the Headwaters Research Proposal Worksheet that you can find linked in the description of the video below. Let's take a look at how today's lesson is going to go. Today, during Lesson 2, you're going to design an experiment to test your question. After today's lesson, you'll be ready to go outside and collect data on your own. During the third lesson, you're going to look at the data and present the findings of your research project. If we look back at this diagram of the scientific process, we're right around the hypothesis stage. During today, we're going to make a hypothesis and plan an investigation to test our question. The first part of designing an experiment to test a research question is to come up with a hypothesis. A hypothesis is your expected outcome or prediction of what you think the results of your experiment would be. It's important to include in your hypothesis a reason why you made the prediction you did. For example, if my question was, how does the distance from water affect the number of trees in an area between my house and the river, my hypothesis could be, there will be more trees closer to the water because trees need water to survive. You can pause this video while you write out your hypothesis and restart it once you are done. The next step of designing a scientific experiment is to create your methods. Your methods are a detailed guide of how you will do your experiment. It's important to be specific when you describe how you will do your experiment. Let's take a look at this example outside to see why that's the case. For example, I'm out here in this forest and I need to decide in my methods how I'm going to decide which one of these many trees to measure and how I do so randomly, so that way I'm not just measuring the tallest or easiest to measure tree. Now that we've looked at that example outside, your job is to come up with your own methods for your experiment. You should include things like, what measurements are you going to take? How many measurements are you going to take? What exactly will you measure? And you should also design your experiment to test only one variable at a time. For example, if I was studying trees in the forest and the effect that both water and sun had on these trees, I would want to make sure that I only tested one of these things at a time. For example, to test water, I would keep the amount of sun that any tree got the same and change the amount of water. To test sun, I would do the opposite. I would test the amount of sun that each tree got, but keep the amount of water the same. You can pause this video while you write out your methods section and restart once you're done. Now that you've come up with your methods, let's pause for a moment and think over your experiment. Does your methods test your hypothesis and help you come up with an answer to your question? I want you to look over those three things, your question, your hypothesis, and methods, and make sure they all fit together. If you need to make changes to your hypothesis, methods, or even research question, now is the time to do that. You can pause the video while you work and restart once you've checked this over. Now that we've come up with a great method for testing our experiment, we have to think a little bit about how variable the natural world outside is. Scientists use something called replicates, which is where they repeat the same experiment multiple times. Scientists use replicates to compensate for how variable the natural world is and to be more confident in their results. If the same thing happens 4 times in a row, that means a lot more than if that same thing only happened once. You can see an example here of a bird feeder experiment that just has mealworms and seeds. This scientist is trying to figure out if birds prefer mealworms more than seeds. As you can see, there are only 2 feeders in this experiment, one with mealworms and one with seeds. This experiment has no replicates. But let's say this scientist put out 8 feeders, 4 with mealworms and 4 with seeds. They would be doing that first experiment 4 times. We would call this 4 replicates. I want you to think about how many replicates it makes sense for you to do to be confident in your results. The next part of designing an experiment is to plan out how you might be able to graph your data. To do this, we are going to make a sample graph of what we think our data will look like if our hypothesis is true. You can draw your sample graph on the part of your worksheet that looks like this. You don't have to put exact numbers on the graph, but be sure to label both your vertical and horizontal axis. Let's take a look at the 2 types of graphs you might be able to use during your project. The first type of graph that you might use to graph your data is a bar graph. The key with a bar graph is that you have numbers on your vertical axis and categories like location, color, or species on your horizontal axis. The next type of graph that you could make is a line or scatter plot. You can use this type of graph to compare 2 different types of number variables. For example, distance from water and height of trees. Take a moment and sketch out a graph of what you think your data will look like if your hypothesis is true. This could be either a bar graph or a line or scatter plot. Pause this video while you work and restart once you've completed this section. The last thing you have to do before going out and starting to do your experiment is to set up a data table to record your data. You have a blank data table in the back of the worksheet you're working on today. Notice how the top row is in bold. We use that to organize the different types of measurements we're going to take. I like the top left column to always be location. Where did I collect that piece of data? If I was studying how the distance from water might affect the number of trees in an area, the next cell on the top right could be the distance from water. The third one along that top row could be the number of trees in an area. I could go out and in the second row down, I might write the location I first collected data, how far I was from the water, and then the number of trees I found at that location. Each time I collected data in a new location, I would start a new row. Take a moment and write down the labels in the top row for the types of measurements you're going to take at each location, as well as you can fill out the left column that describes what locations are you going to go out and collect data to. This will help you plan out your experiment. Now that you've planned out your experiment and set up your data table, you're ready to go out and try out your experiment. An important part about this is to test out what works and what doesn't work, and then revise your experiment. Scientists call this preliminary data. This is what they use to see how well their experiment and methods are working so that they can make adjustments so that the rest of their experiment runs really smoothly. The first time you go out and collect data, think about how you might be able to improve your experiment and then make those changes to your methods. The other thing to think about when you're collecting data is how not to be biased in your sampling. Sometimes it's easy for us to go outside and measure the largest or most exciting things in our sample area. It's important to do this randomly so we don't bias our results. Ways you can randomly choose how to sample is choose a number between 1 and 100 and count that many steps. You can also spin around in a circle with your eyes closed and throw something small as a marker like a tennis ball. Then you can measure the number of whatever you're looking at, such as plants, where that tennis ball landed. Keep both of these things in mind when you're trying out your experiment and thinking about how you could improve your methods. Nice job, everyone. That's the end of today's lesson, but before we go, let's check over the homework you have before next lesson. Your first thing is to go test out and revise your experiment. Collect preliminary data and then improve your methods. The second part of your homework is to do your data collection. This can take 4 to 5 hours outside, and you can spread this out over multiple days if you don't have enough time to do this all in one day. The third and final part of your homework is to enter the data that you collected into a spreadsheet. When you're entering this data into a spreadsheet on a Excel or Google sheet, it's important to include only numbers or letters in any one cell. If you put numbers and letters in a cell, it might make it hard for the computer to make a graph of it later. That's all for today's lesson 2. Good luck with your data collection, and remember, the more data you collect, the more confident you can be in the results that you find. We'll see you back here for lesson 3 once you've finished your data collection and have entered all your data into a spreadsheet.